Is this a solve or factorize question? What happens next, guys, is this. Uh, what we have is 2 over 9 equals 1 over x minus 5, 1 over x plus 1. Now, when you're doing fractions normally, guys, all fractions, if you're doing something as easy as, I don't know, 1/3 minus 2/5 plus 3/7. Do you remember doing something like that in junior cert level? Okay. Okay, guys. What I was saying here is that you used to give them a common denominator, didn't you? Now, another way of getting a common denominator is for the 3 to look at the 5 and the 7 and realise that if I was to write this out again with a bit more space, 1 over 3 minus 2 over 5 plus 3 over 7. What I can do here is this. The 3 looks at the other two denominators and it says, well, if I had a 5 and a 7 underneath, and this one's going for a 3 and a 7, and this one's going for the 5 and a 3. Now, what you put on the what extra you put on the bottom, you also have to put onto the top. So that'll be 5 7. Yeah, this one here, 3 7. After that, 3 5. And then what you can do is all the denominators are the same, so they're all going to be 15 times 7 is 105. Okay, the denominator is 105. So what happens, you're going to get 35 for this one here. 1 multiplied by 5, 5 multiplied by 7, 2 multiplied by 3, multiplied by 7, and then 3 by 3, plus 5, and then, lo and behold, it's 38 over 105. Now, the system we used here with the extra denominators, it carries through with more complicated questions. So more complicated questions like question 6 that we have on the board. All that we have to do is draw it out again. Now, what happens here, guys, is the same thing. 2 over 9 equals 1 over x minus 5 and 1 over x plus 1. Now, this 1, put the 1 to the front. Now write out what's extra. So what's extra on the bottom beside the 9? And that's extra. What about this one? Now see the way I'm sort of keeping them in the same order? That's just handy, right? And the last one? X minus 5 and the 9, yeah? Now what I put extra on the bottom has to be extra on the top. So this one's going to be a 9 and a x plus 1, and then the last one, x minus 5, okay? Now, important thing to remember is you do it in 2 steps. Multiply this by 2 first and you get 2x minus 10, and that's going to be multiplied by x plus 1. Any questions on that part? I just have to do it again next step over. 9 times 1, 9. 9 times x plus 1, 9x plus 9. Minus 1 times 9, minus 9 times x minus 5, plus 45. Okay, good man. Now, what we're going to be doing next is this. We are going to multiply this out. Now, some of you are probably wondering, what happened to the bottoms? I'm just about to cancel them. Now, the reason why I'm able to cancel them is because of this. If I had 2 over 5 plus 4 over 5 equals 6 over 5. If I had a balanced equation like that, yeah? Is everybody looking? If I had a balanced equation like that, what can I do with the denominators? And does the equation still balance? So you can see that when things are balanced, if the denominators are the same, it's the top parts that cause the balancing effect. Would you agree with that? So therefore, when all the denominators are the same, we're only concerned with the top part regards the balancing parts. So 2x times x, 2x squared. 2x times 1 plus 2x. Minus 10 times x, minus 10x. Minus 10 times 1, minus 10. On the other side, 9x take away 9x, Nothing. 9 plus 45? 54. Okay, then after that, 2x squared. What's 2x minus 10x? Then bring over the 54 over to your sides. Minus 64. Here's your options. You can do a minus b formula, where a equals 2, b equals minus a, c equals minus 64. You can divide both sides by 2 if you want. Yeah? And why am I able to divide both sides by 2? It's a balancing act. So example B, 8 minus 8 is 0. Divide by any number you want. Divide by 4 even, or divide by 2, and it'll just become 2 minus 2 equals 0. So it maintains the balance is the main thing. Yes? You have to solve it then. So you'll see the question says solve. What you're going to do next, guys, is you can divide by 2 and you get 8x squared minus 4x. What was it? Minus 32. Two numbers, minus reference number, a minus 8 and a plus 4. I'm not going to be doing those ones too slowly anymore. And then finally two answers, x equals 8 and x equals minus 4. Okay, question 12, okay? What does the answer suggest to us? It's the same type of question. We're solving one of these, but what does the answer suggest to us? Suggest the minus b formula because it's in surd form. S-U-R-D. Surd form. Is that alright? So how do we do this then, guys? Somebody tell me what to do. Okay, perfect. Multiply them by what they don't have. What does the x not have? 3 and x plus 1. What about this one here? 3 and x. Just keep them the same order. This one here. Okay. Now on top, what do we have? What do we have on top here? Good. Well done. After that, 3 and x. After that, x and x plus 1. Okay, what happens to the denominators? Why? Because the equal sign into the solved question. Perfect. So a equals 1, b equals minus 2, c equals minus 6. So what's minus b? Plus 2. But I get what you were doing. Okay. So 2 plus or minus the square root of. So what do I put in? Minus 2 squared, yeah. 1 minus 6. All divided by. Okay, 2 times 2. Oh, sorry, 2 times 1. Yeah. Now, can somebody in the class tell me, just put this into your calculator for me, can somebody tell me what that's 4? That's going to be 4 plus 24. Can anybody tell me what root 28 is? I think it's 2 root 7. Okay. So it's either going to be 2 plus or minus 2 root 7 all over 2. Divide both of them by 2. Does everybody remember that fractions, if you're adding fractions, as an example, 7 plus 2 over 5, that is the same thing as adding 7/5 to 2/5 separately. So when there's a minus or a plus in the middle, the fraction, the denominator, acts on both of them. Does that make sense, Max? Okay. 2 divided by 2? 1. 2 root 7 divided by 2? Root 7. Does anybody not get the 2 root 7 divided by 2 part? Does anybody need extra explanation there? I'll give it anyway. It's the same thing as 2x over 2. The 2's cancel, leaving the x behind. 2's cancel, leaving the root 7 behind. And that's it. Okay, guys. Please, okay? So, guys, what we're going to do is going to construct the equation here. A numerator of a fraction is 8 less than its denominator. First of all, in a fraction, the numerator is the top number, and the denominator is the bottom number. Always. Now, the next thing is, in really basic terms, in this question, which is the bigger number, the numerator or the denominator? It says the numerator of a fraction is 8 less. So the denominator is the bigger number and the numerator is the smaller number. Okay? Now, what's going to tell me next is if the numerator is x, and if I chose x minus 8 on the bottom, which is the bigger number, x or x minus 8? Which one's bigger? X is bigger. So x minus 8 should be bigger than x. That means you made the wrong call. How much bigger is the denominator than the numerator? 8 bigger. So x plus 8. Now, what does it say about this fraction in part 2? So that's part 1. Write the denominator is x plus 8. Now, what can we do with this fraction then? What can it be broken down into? 3 over 5, yeah? Write an equation to represent this information and hence solve for x. So look, any ideas how to solve that? Same stuff, isn't it? The x looks over the other side and goes, I'll have a 5 top and bottom. The 5 looks over the other side and goes, I'll have a x plus 8 top and bottom. Now what happens to the denominators? And what are we going to be left with? 5x equals 24. 2x equals 24. X equals 12. Now, x is 12, right? What is the actual fraction? 12 over 20, which can be broken down into 3 over 5. Everybody happy enough with that? Any questions? So guys, if I was to change this question to 20 pupils in the class, every pupil, the total number of posters the pupils have to make is 100 posters. We have to make the same amount each. If we had 20 pupils, how many posters would we make each? 5. How did you do that? Using language though, using English language. You got your number of posters and you divide it by what? Number of students. That's what you do if it was real numbers, and that is exactly what you'll do even when it's algebra. So the number of posters made per student is 100 over x. That makes sense? Okay, any questions on that now? Now, the next thing, part 2. On the day they were making posters, 5 pupils were absent. 5 pupils were absent. How many pupils were in then? X minus 5, excellent. So that means x minus 5 pupils were x minus 5 were in, is what we can say. And each pupil present had to make 1 extra poster. They had to make 1 extra poster. So, if we use this formula again, for scenario B, when you're a student down, yeah? Or so when you're 5 students down, we still have 100 posters to make, don't we? And the number of students has been decreased to x minus 5, okay? Now, here's the real question, alright? When there's less people to do the posters, does each student have to do more work or less work? More work. So this basically, this answer here results in more posters compared to the original answer, which will be a smaller number, isn't it? Would everybody agree with that? I'm going to pause it here. What this means is that if we were going to make 100 minus x posters each, people didn't turn up, so we had to make 100 over x minus 5 each. Which one's the bigger number? Which one's the bigger number again? I know, the 2 green boxes, which one's the bigger number? The second one, because that's when we make more posters, because there's people missing. So the big number equals the small number plus 1. Where did I get the 1 from? Each student had to make 1 extra poster. So basically scenario 2 involved 1 extra poster. So that's why scenario 2 is the big number, and it equals your original number plus 1. To express this as an equation, guys, 100 over x minus 5 equals 100 over x plus 1. Okay. Okay, guys, just remember for your homework, which you'll be doing over midterm, you're going to have to finish that off, and you're going to have to get a positive answer for x. So you won't be finished until you get a quadratic equation and 2 answers for x. Everybody happy enough with that? Now, next one. 140 students are taking place in a drill display arranged in rows containing equal numbers of students. So what we have here is like a bunch of rows, and each row contains the same amount of students. So example would be something like this: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These are the rows. The red lines represent the rows. The blue X's represent 4 students per row. Everybody happy with that? Now, this is an everyday example. Has nothing to do with the question just yet. 140 students were arranged in rows containing equal numbers of students. Every row contains the same amount of students. To facilitate 4 new students, 1 extra student was added to each row. It was found that 2 fewer rows were required. How many students were originally in each row? So, in a nutshell, what the type of question they're asking me is this. Imagine that I currently have 16 students, right? Would you agree with that? Imagine I had 1 less. Yeah? I have 1 less. I originally had 4 rows. Now I have 1 less. Now, the deal is that I have to have the same amount of students in each row. Would you agree with that? So I can't maintain the current arrangement. So what I have to do instead is I take these guys up, and unfortunately for me, well, there you go, worked out quite well. I moved them. I had 4 rows, now I only have 3 rows. That's the type of question we're being asked. That's the concept, okay? So let's put this into action, okay? Using a quadratic equation or a fraction equation. So what we're going to do is this. How many rows are we using? It was found that 2 fewer rows. The language is about fewer rows, okay? Number of rows in first place. How much rows did we use in the first place? Equals 140 students divided by what? How many students were originally in each row? 140 divided by x. What does x stand for? The students in each row. Do you have a question? Now, what I have next is, guys, 140 divided by x. 140 is the number of students. X is the number of students I put per row. As an example, if I were to put 10 students per row, it would result in 14 rows. Would you agree with that? 140 divided by 10. So, now here's what happens. What happens next is 1 extra student was added to each row. 1 extra student means that it's going to be x plus 1. If I have an extra student per row, does that mean more rows or less rows? Go. Okay. 140 divided by x plus 1. Which number is bigger, guys? X or x plus 1? X plus 1. Therefore, which number is smaller? The one, box A or box B? Now, here's the deal, Rory. 140 divided by, I don't know, 10 as an example. The x plus 1 is guaranteed to be a bigger number, so 140 divided by 11, therefore 140 divided by 11 is a smaller number than 140 divided by 10. So, once you figure out which one's the big one, which one's the small one, it becomes really easy. This is the big one, this one is the smaller one. Now what does it say next? 2 fewer rows were required. 2 fewer. So, the big number equals the small number plus 2. Therefore, the equation now becomes 140 over x equals 140 over x plus 1 plus 2. Solve that equation for x. Is that alright? So,